Welcome to qnawire.
The radial probability distribution for this state is given by PR equals to 4 pi r squared times the absolute value squared of psi 300 squared. And this is equals to 4 pi r squared. Note that psi 300 is just a real function, so we just have to square it to get 27 pi r0 cubed divided by 1 times 1 minus 2r divided by 3 r0 plus 2r squared 27 r0 squared times z to the minus 2r divided by 3 r0. And this is equals to, one can simplify pi with pi, so we got 4 r squared e minus 2r divided by 3 r0 divided by 27 r0 cubed times, so 1 times 1, just 1, minus 2r divided by 3 r0 plus 2r squared divided by 27 r0 squared. Now we have minus 2r divided by 3 r0 plus 4r squared divided by 9 r0 squared, which is this term times this term again. Now we have this term times the next term, which is minus 4 r to the third divided by 27 times 3 is 81 r0 cubed. And finally we have 2r squared divided by 27 r0 squared minus 4r cubed divided by 81 r0 cubed plus 4r to the fourth divided by 27 squared r0 to the fourth. Now we can simplify this equation a bit to get 4r squared e minus 2r divided by 3 r0 divided by 27 r0 to the third times 1. So we have this term, which is minus 2r divided by 3 r0, this term again, and that's it. So minus 4r divided by 3 r0. Now we have this term, which is divided by 27 r0 squared, this term, which is also divided by 27 r0 squared, and this term, which is divided by 9 r0 squared. So we can write it as follows. We have 4r squared plus, well, we have to multiply by 3 both the numerator and denominator, then we get 12r squared, and this is all divided by 27 r0 squared. And finally we have this term and this term, which is repeated, so we get minus 8 r to the third divided by 81 r0 cubed plus 4 r to the fourth divided by 27 squared r0 to the fourth. And finally we get PR as being equals to 4 r squared e to minus 2r divided by 3 r0 divided by 27 r0 to the third times 1 minus 4r divided by 3 r0 plus 16r squared divided by 27 r0 squared minus 8r to the third divided by 81 r0 to the third plus 4r to the fourth divided by 27 squared r0 to the fourth. On the next item we have to sketch the graphic of that curve, and note that this is a quite tough task to do without using a computer, But there is one thing we can do, which is a brief sketch of that function only. Remember that xi 3, 0, 0 is equals to square root of 27 pi r0 to the third divided by 1 times 1 minus 2r divided by 3 r0 plus 2r squared divided by 27 r0 squared times z, the minus r divided by 3 r0. So we have a product between this term and the graphic of this term is a decaying exponential. So as r tends to infinity, this tends to 0. As r tends to 0, this will tend toward 1. So we have 1, and this goes to 0. And this is the plot, the sketch for the graphic of this first part. And then we have the second order polynomial. The graphic for that kind of thing is a parabola, as we know, but now we have to calculate what is the discriminant of that parabola to know if it has 1 root, 2 root, and where the roots are. This is a fairly simple task to do. Well, we can do it as follows. So the discriminant is equals to b squared, so this term squared, then 4 divided by 9 r0 squared minus 4 times the first term, 1 times the last term, 2 divided by 27 r0 squared. Then this is equals to 4 divided by 9 r0 squared minus 8 divided by 27 r0 squared. And this is equals to multiplying by 3 here and here. We have 12 minus 8 divided by 27 r0 squared, and this is equals to 4 divided by 27 r0 squared. This means that we have two real roots. Now the roots are r is equals to minus b, so 2 over 3 r0 plus or minus the square root of delta, which is 2 divided by the square root of 27 r0 divided by 2. They simplify, and we get 1 divided by 3 times r0 plus or minus 1 divided by square root of 27 r0. We can multiply both the numerator and the denominator by the square root of 27 to get 1 divided by 3 r0 plus or minus 27 divided by the square root of 27 r0. Now we can multiply here and here by 9 to get r is equals to 27 plus or minus 27 divided by 27 times r0. Oh, I forgot to include the square root here. Then r is equals to 1 over r0 plus or minus the square root of 27 divided by 27 r0. So we have two real roots. One is 1 over r0 plus square root of 27 divided by 27 r0, which is bigger than 0, and the other one is also bigger than 0, because the square root of 27 divided by 27 times r0. Note that square root of 27 divided by 27 is the same as 27 r0 under 1, and this fraction is smaller than this fraction, so the whole is bigger than 0. So the graphic of the polynomial is as follows. It's a parabola that crosses the x-axis twice. We ignore this piece of the graphic because r can only be bigger than 0. Then we multiply this graphic by the other one, which goes like this. And we get the following. As a result, we have a decaying graphic because of this section of the parabola. So it decays and becomes negative because these values are negative and it's always multiplying positive values here. So we have something like that. Then it starts to go up again because of this part of the parabola. But at some point, the decay of the exponential gets quicker than the increase of the polynomial. This will increase as r squared and this decrease as e to the minus r. So this will always win the race. Then at some point it will start to decay again and it will tend towards 0. And this is a sketch for psi 300. Using that sketch, we can produce another sketch for the absolute value of psi 300 squared. And this is something like that. So this part, which were negative, we just have to invert it. So now it's positive because of the squared here. And that's it. Now remember that PR is equals to 4 pi r squared times psi 300 squared. The plot for r squared is very simple. It's simply a parabola, an ever increasing half parabola. So all we have to do is multiply this by the previous plot. We sketch it. And this results in the following. So again, it will always lose the race because the decay here is exponential. So at the end, we will always have something tending towards 0. And then this parabola here starts at 0, so it makes that portion of the graphic begin at 0. So it goes like this. Then increase again, then increase again, and then goes towards 0. Why these peaks are increasing? Because they are enveloped by this parabola. So this do something like that. And finally, this is a sketch for PR. Now we have to solve and discover what is the most probable radius for the electron. And to do that, we have to solve the following equation. The derivative of PR with respect to r is equals to 0. Note that by taking the derivative of PR with respect to r, we will get a very complex polynomial, and it has no exact solutions. So unfortunately, we have to plug in it on the computer to solve this for us. We expect to get 1, 2, 3, 4, 5, 6 solutions, and we will only want this one. By doing that, one gets that the maximum happens at r approximately 13.1 times r0.